Hi guys, it's Mrs. Tucker. This is Chapter 11 review on exponential functions. This is just lessons 11-1 through 11-4. So let's get started. This part doesn't have 11-1 in it, but I do have some review questions covering 11-1 at the end. Okay, so the first part's going to be 11-1, 11-2, and 11-3. All right, on your review, the first one says solve the equation 3 raised to what power equals 2,187? And at this point, it's just guess and check for you guys. Unless you remember what I taught you about using the log, which really it's beyond the scope of this class. It's really just going to be guess and check. Is it 3 raised to the 4th power? Is it 3 raised to the 5th power? Is it 3 raised to the 6th power, or is it 3 raised to the 7th power? Did anyone get the answer?
Yes.
Yes, ma'am. What is it?
7.
I hear 7. Did anyone else get 7?
Yes.
Did you put this in your calculator? 3 raised to the 7th power, and did you get that for an answer?
Yes.
Okay, then the answer there is D. Number 2, a city's population is increasing at a rate of 2% per year. What type of model describes this situation? We have a rate of increase of 2% per year. Is that linear? Is that exponential, or is that quadratic, or is it none of these?
Exponential.
Yes, if you've got a rate of increase of 2% per year, that means that you're multiplying each one of your numbers by 1.02, and that's going to be exponential. You're going to have y equals some initial number multiplied by 1.02 raised to the x. That's exponential. Number 3, in the exponential function, f of x equals a times b raised to the x, a represents what? Is it the common difference, the y-intercept, the constant ratio, or the x-intercept? Ooh, in y equals a times b raised to the x, the a is what?
Y-intercept.
What's always true of your y-intercept?
X equals 0.
And if you make your x 0 here, a times b raised to the 0, any number raised to the 0 power is what?
0.
1.
Oh,
1. And 1 times a is a. So isn't it 0 comma a? Isn't that your y-intercept?
Yes.
That's your y-intercept. Yes. Number 4, which data set is best modeled by a quadratic function? What's true of quadratic functions? They have a what? A common second difference. So I'm going to give you guys time to figure this one out. Check for a common second difference. Sure got quiet in the room. Okay, you're looking for a second common difference in your y's. So I always check out my x's first. Those are all increasing by 1. That one increased by 2. That one went back 6. It's not a. Let's see, my x's are increasing by 1. Here I increased by 4. I'm sorry, I increased by 2. Here I increased by 4. Here I increased by 8. Here I increased by 32. Looks like I'm multiplying by 2 each time. That one is exponential. So it's not that one. Let's see, here my x's are all increasing by 1. My y increased by 2, increased by 2, increased by 2, increased by 2. That one's linear. It's not that one. So I'm guessing it's this one, but you still need to double check it. X's are increasing by 1 each time. My y, what happened here? What happened from here to here? What happened from here to here? Whoops, not an increase of 1. Let me back that up. That's a decrease of 1. Oh, decrease of 1. Decrease of 4. What happened from here to here? Decrease of 3. What happened from here to here? And what happened from here to here? Did we find our quadratic? Yeah, it's D. D is quadratic. Okay, question number 5. It says, which function is not an exponential decay model? You know, exponential decay, if you were to graph, exponential decay starts and goes like this, okay? As your x values are increasing, your y values are decreasing. This is the perfect kind of question to use a graphing calculator with, and just plug the equations into your y equals and see what happens. So I'm going to switch over here. I've got a graphing calculator right here. I just went online and I just Googled graphing calculator, and this is what popped up. So if you don't have one at home, use one of these. Pause the video, Google graphing calculator, and this is the one from my.hrw.com. Go ahead and give that a try. Do that yourself. Pause the video and I'll wait on you. And you're going to use y1 and y2 and y3 and y4 for each one of your 4 answer choices. Okay? Meet you in a minute. Okay, so I'm going to input the first one. Number 1 says y equals 5 times 1/3 raised to the x. When you graph that, it looks like this. That is exponential decay. As x increases, your y's are decreasing. Okay, so I'm going to go put in the next one. The next one says -5. Let me put a negative in here. -5. Let's graph that one. Graph. Okay, that one is increasing. My y's are increasing as my x's are increasing. Let's try the next one. Put that in there. Let's see the difference between, let's see, that's going to be 3, not 1/3. So let me take that out. It says 5 times 3 raised to the negative x. Let me put a negative in there and let's graph that. That one is identical to the first one. Isn't that weird? Okay, well, it kind of makes sense because any number raised to the negative power is 1 over that. Kind of makes sense. And then the last one, let's see here, says y equals 5 times 3 raised to the -1. So raised to the -1 power, then raised to the x power. And let's graph that one. That one's going to turn yellow. Oh, so I'm seeing that A, C, and D are all the same graph. The one that doesn't fit, the one that's not decaying, is this green one, and that's B. Okay, -5 times 1/3 raised to the x. So right here, it looks like it's B. All right, moving on. Which function best models the data? Okay, you know what? I really like to have a little table. I'm going to set this up in a table. My x values and my y values, I can just see it better that way. -4, -2, -2, -1, 0, 0, 2, 1, 4, 2. All right, pause the video and take a look at that. See what you think. Okay, as my x's increase by 2 each time, I'm going to check out what my y's are doing. Increase by 1, increase by 1, increase by 1, increase by 1. So looks like I have a constant change in my x that correlates to a constant change in my y. That tells me it's linear. And linear is y equals mx plus b. That's the basic form, slope-intercept form for linear functions. Your slope is the change in your y's divided by the change in your x's. My y's are increasing by 1. My x's are increasing by 2, so my slope is 1/2. So it's y equals 1/2 x plus my y-intercept. Your y-intercept is always where your x equals 0, so you can add on 0, but we don't normally do that. That's the equation that goes with this data, and so your answer here is C. Yeah, look at how much you've learned this year. Number 7, a population of 500 is decreasing at a rate of 10% per year. Which function models this situation? Okay, well, this is a situation of exponential what? Is this exponential growth? Is that compound interest? Is that exponential decay? Or is that half-life? Well, this right here gives you a clue. This is what? This is exponential decay. And the base formula for exponential decay is y equals your initial value multiplied by the quantity 1 minus your rate raised to the t power. Okay, our initial value, we started off at 500. Y equals 500. 1 subtract your rate of decay, that's 10% per year, but that's got to be in decimal form, so subtract 0.10 raised to the t, we get 500 what? Yep, multiplied by 0.9 raised to the t. So your answer here should be C. Are you checking your answer bank? Gave you guys an answer bank to make sure you're getting these right. Okay, let's move on. Got that one right. Whoops. Number 8. Stephanie wants to save $1,000 for a down payment on a car, which she wants to buy in 3 years. She opens a savings account that pays 5% interest compounded annually. About how much money should Stephanie deposit now to have enough money for the down payment in 3 years? Okay, first of all, this is compound interest, so I need a formula. What's that formula? A equals what? Look it up. You're going to need this for tomorrow. Your principal amount multiplied by 1 plus your rate in decimal form divided by the number of compounding periods raised to the nt. N is your number of compounding periods and T is your time in years. All right? P is your principal, or the initial amount of money that you're saving. Well, that's what we don't know. About how much money should she deposit now? That's this right here. That's what we don't know. But eventually we know that she wants to save $1,000. That's what goes right there. So $1,000 goes in here. P is what we're solving for. 1 multiplied. What's my interest rate in decimal form? What is that in decimal form? Be careful. It's not 0.5. 0.05 divided by, if we're compounding annually, n equals what? Okay, you might want to take a look at your notes to make sure you know all those n values. Compounding annually means your n equals 1. Raised to the 1 times t, and our time is 3 years. Okay? So we've got 1,000 equals P times the quantity. Well, 0.05 divided by 1 is 0.05. So this is 1.05 raised to the 3 power. All right, now our goal is we're trying to solve for P. How do you undo multiplication by this thing right here? Yep, you've got to divide both sides by that. So you get P equals $1,000 divided by 1.05 raised to the 3rd power. Run that through your calculator and let's see what you get. 1,000 divided by raised to the 3. What'd y'all get? I got 864, which is really close to 865. So on this one, the answer is D. Okay, they must have done some rounding that I didn't do. So that's number 8. Is that what's in our answer bank? Okay, let's go on to number 9. I can't even pronounce this. Technetium 99 has a half-life of approximately 6 hours. The original measurement for the mass of the sample was lost. After 24 hours, 20 grams of that stuff, technetium-99, remains. How many grams was in the original sample? Okay, now this is a half-life, so I need that formula. You got your notes handy? What was that formula for half-life? The amount at the end is the amount you started with, multiplied by 0.5 raised to the t. Now be careful. Right there, that's important. T is not time. T is the number of half-life cycles that the stuff goes through in the given time period. Okay? Now, the original amount is lost. We don't know the P. That's what we're trying to solve for. After 24 hours, there's 20 grams remaining. That's your A. So we have 20 equals P multiplied by 0.5 raised to the T. T is the number of half-life cycles that this has gone through in the given time period. It has a half-life of approximately 6 hours. It says after 24 hours. That's your given time period. Okay? So in 24 hours, it's gone through 6 half-life cycles. It has a half-life of 6 per cycle. That's 4 cycles. So that's what you raise your 0.5 to. The number of cycles in the given period. There's 24 hours. Each 6 hours, half of it's gone. So that's 4 cycles. All right? Now we're going to solve for P. How do you undo multiplication by 0.5 raised to the 4? Yeah, you divide. So we've got 20 divided by 0.5 raised to the 4, and that gives you what? 20 divided by 0.5 raised to the 4th power. What'd you get? I got 320 grams. Answer choice D. Is that the correct answer? Check your answer bank. Okay, moving on. Number 10, a realtor estimates the new house worth $500,000 will gain value at a rate of 6% per year. Make a table that shows the value of the house for years 0, 1, 2, 3, and 4. What is the real world meaning for year 0? Which type of model best represents the data in your table? Explain. Write a function for the data. Okay, there's a lot happening here. The first thing they want us to do is make a table. All right, so let's make a table. This is going to be, let's see, they want you to make a table that shows the value of the house for years 0. So this is going to be my years. 0, 1, 2, 3, and 4. And this is going to be the value, or what they called worth. All right, so now, is this exponential growth, compound interest, exponential decay, or half-life? Yeah, this is exponential growth. Y equals, what was that formula? Does that look right? Yeah, I think that's right. A is your initial amount of money. So we have Y equals 500,000, 1 plus R. Now your R has to go in decimal form. Be careful here. 6% is what is a decimal? No, it's not 0.6. It's 0.06. So I'm going to take 0.06 and add it to 1, and we get 1.06 raised to the t. Okay? So you can work that out, or I'm going to just put it in my graphing calculator. $500,000 multiplied by 1.06 raised to the x power, and then I'm going to go to my table. All right, what'd you get? I want you to do this. If you don't have a graphing calculator at home, you can use that online graphing calculator and check out what table it makes. After 1 year, the value of the house is, After 2 years? Okay, so at year 2, I kind of got cut off there. Year 2, what'd you get? I got 631,238. At year 3, what'd you get? I got 844,739. At year 4, woo, this number got big. It says on my calculator 1.27 E6. That's times 10 to the 6th power. That means I move my decimal place 6 places to make it really big. 1.27, that means 1, 2, 3, 4, 5, 6, 0, 0, 0, 0. Put in my comma, 1,270,000. All right. There's my table, my chart. Make a table that shows the worth of the house, the value of the house for years 1 through 4. Check. What is the real world meaning of year 0? What does this mean? And what does that mean? Year 0 is the year the house was new. Brand new house, it was worth $500,000. Check, got that done. What type of model best represents the data in your table? What did we do right here? Yeah, that's an exponential model. We knew it was exponential because they gave us a rate of change, that the value was gaining 6% per year. Check, explain. Oh, I explained. Write a function for the data. Well, we did that. Okay, I'm guessing we probably did this whole problem backwards. All right. We probably should have done the values of the house first and then worked into that, but we're kind of too smart for that, aren't we? Yes, we are. Okay, let's move on. Question number 11 says, the function f of x equals 50 times 0.917 raised to the x, where x is the time in years, models a declining lemming population. Do you know what a lemming is? Yeah, Google that. Tell me what a lemming is. How many lemmings will there be in 9 years? Well, they give us a function. F of x equals 50 times 0.917 raised to the x, where x is the time in years. They want to know how many will there be in 9 years? Yeah, just replace that x with 9. Tell me what you get. Grab your calculator. 50 multiplied by 0.917 raised to the 9th power. Got my answer. Do you have yours? Now you need to round because you know you can't have a part of a lemming. I believe it's a bird. All right, what did you get? I got 22.9, so I'm going to round that to what? Yeah, 23 lemmings. All right, number 12. Tell whether the function y equals -3 times x to the 8th is exponential. Explain your answer. You know what? I got a graphing calculator handy. I'm going to hit y equals, clear out that equation. I'm going to put in -3 times x raised to the 8th power, and then I'm going to graph it. Now, if you don't have a graphing calculator at home, why don't you Google that online graphing calculator? I'd even bookmark it. If you don't have one at home, do that. You need to take a look at the graph and see what you get. Okay? Is it exponential? You tell me. You can look at the formula and tell me why it's not exponential. You don't necessarily have to graph it. Does it follow that base form? Y equals a times b raised to the x. Does it follow that base form? Does it follow that base form? Yeah, it doesn't. When you graph it, you get something that looks kind of like a quadratic. It's not a quadratic though. All right, so take a look at that graph. The answer here is no. Tell me why. Number 13. In the year 2000, the population of Mexico was about 100 million, and it was growing by 1.53% per year. At this growth rate, the function f of x equals 100 times 1.0153 raised to the x gives the population in millions x years after 2000. Using this model, in what year would the population reach 109 million? Round your answer to the nearest year. Okay, we have our starting population, 100 million, 100, and they rounded it to, this is millions, so that 100 is 100 million. 1.0153, do you see that they changed our percent to decimal form by moving the decimal point 2 places to the right? Okay, that's where that comes from. They added it to 1 because that's a growth function, exponential growth, raised to the x, where x is the time in years. After 2000, it says, in what year would the population reach 109? We're going to set this equal to 109. Okay? So the first thing I'm going to want to do is divide both sides. I want to get rid of that multiplication by 100, so let's divide both sides by 100. Okay, so take your 109, divide by 100, and you get 1.09 equals 1.0153 raised to the x. Now, I haven't taught you how to, well, I kind of talked about using your log button on your calculator, but don't do that. Right now, this is really kind of a guess and check. We're wanting to know how many years after that, so put in an x of 1. Well, I know that's not going to be it. Put in an x of 2. Put in an x of 3, okay? Or what you can do is put that in your graphing calculator and look to see what x value gives you that for your y, all right? Give it a try. Let's see what happens. Okay, I did my guess and check. Raised to the 6th, 1.0153 raised to the 6th power gives you 1.095. That's pretty close. So it's in 6 years. They want to know in what year. Well, this is 6 years after this date, so what's the year where the population equals that? Yeah, 2006. That's your year. Okay? Let's take a look at 14. The value of a gold coin picturing the head of the Roman Emperor Marcus, I can't even pronounce that, is increasing at a rate of 12% per year. If the coin is worth 140 now, what will it be worth in 9 years? Okay, so this is exponential what? Yeah, it's increasing, so this is exponential growth, which is y equals what? What was that formula? Your current value, your original value, times the quantity 1 plus your rate in decimal form raised to your time. Let's see, our original value, the coin is worth, if the coin is worth this now, so it's 140 now, your rate has to be in decimal form, so 12% is the same as 0.12. Add that to 1 and you get 1.12 raised to the t. What will it be worth in 9 years? So in place of t, we're going to put in what? Yeah. Now it's just number crunching. 140 multiplied by 1.12 raised to the 9th power gives you what? How much is that coin worth? I got, what'd you get? I got $388.23. All right. Moving on. Number 15, a radioactive isotope has a half-life of 7 hours. Find the amount of isotope left from a 320 milligram sample after 42 hours. If necessary, round your answer to the nearest 1,000. Did I forget to round back here? Round your answer to the yeah, I rounded. Okay. All right, we've got radioactive decay. That is a half-life. What was that formula for half-life? Now remember, T is not time. Time is the number of half-life cycles in a given time period. All right, so our initial amount was that 320 milligrams. Okay, a radioactive isotope has a half-life of 7 hours. How many half-life cycles does it go through in 42 hours? It's going to be 42 divided by 7, which is 6. That's how many half-life periods it goes through in 42 hours. So you raise that to the 6th. Now just do some number crunching. What'd you get? I got 5 milligrams. Bam. Okay, let's take a look at 16. Write a compound interest function to model the following situation. Then find the balance after the given number of years. Okay, well, our compound interest formula says what? Do you remember it? Your principal amount, your beginning amount, times a quantity, 1 plus your interest rate in decimal form over the number of compounding periods per year, raised to the number of compounding periods per year times your time in years. Okay, so we have $18,600 invested at a rate of 3%, compounded quarterly. Compounding quarterly means what? You guys need to go back to your notes and review this. Compounding quarterly means every 3 months. So how many compounding periods do you have per year? Yeah, that's going to be 4. And we're doing this for 3 years. All right, so let's just plug them all in and see what we get. 18,600 times the quantity, 1 plus. My interest rate has to be changed to decimal form. Be careful here. That is not 0.3. A lot of people make a mistake right there. My n, since we're compounding quarterly, is 4. And we're doing this for 3 years. All right? So do your orders of operation. Do this first, then raise it to the exponent. The last thing you're going to do is multiply by this. All right? Let's see what you get. Okay. All right, they wanted you to write the compound interest function. That was the first thing they wanted you to do. That's that part. Then they wanted you to find the balance after 3 years. I got a balance after 3 years of $20,345. Is that what you got? Well, good job. Okay, moving on. Number 17. They want you to graph this, okay? And you can build one of these, an XY table. Pick 0, 1, 2, 3. Since this is a naked problem, you'd probably want some negatives also. -2, -1, 0, 1, 2. All right. Plug those into your equation, get your y values. Alrighty? Here's what I got. Now, I would use graph paper. I would do a good job of this. All right. My y-intercept is where x equals 0. My y-intercept is 4. Okay. And I ran out of room here. But your graph's going to look something like this. And I want you to scale out your graph. Don't do what I just did. Scale it out nice and pretty. And graph that thing. Graph it out good. All right, moving on. I'm about to run out of time here. I may have to I'm going to finish this up in a moment. Alrighty, number 18. The fish population of Lake Collins is decreasing at a rate of 1% per year. In 2004, there were about 1,350 fish. Write an exponential decay function to model this situation. Then find the population in 2009. Okay, exponential decay. Your formula is this. Okay, our starting population in 2004 was this, 1,350. Multiply that by 1, subtract your rate of decrease. Don't put in 0.1, you're going to put in what? 0.01. Raised to the, what's your amount of time? Well, I think they want you to just write the decay function. So we're going to put in y equals 1350 times 0.99 raised to the t. There's your function. All right. Now they want to know, find the population in 2009. Well, from 2004 to 2009, that's 5 years. So we're going to replace t with a 5 and find out what our population is. Now it's decreasing, so I know the number should be smaller. 1350 multiplied by 0.99 raised to the 5th power. And what did you get? And don't forget, you can't have part of a fish. Well, I guess you can if you're eating it. I have 1,280, about 84 fish. Is that what you got? Somewhere in that neighborhood? Yeah, that's what I got. All right, moving on, number 19. Look for a pattern in the data set. Which kind of model best describes the data? All right, well, I notice all of my x values are increasing by 1. That's good. Now I need to look and see what's happening here. It goes to 2,000 to 5,000. That's an increase of 3,000. This from here to here is not an increase of 3,000. So I know it's not linear. And it looks like it keeps growing. It could be quadratic, but I'm very suspicious. I think it's probably exponential. And you know what? This right here, the title, kind of gives me a clue also. Population growth. I'm thinking it's probably exponential. So I'm going to take 5,000 and divide by 2,000. I multiplied by 2.5 here. I'm going to take 12,500 and divide by 5. Whoops, I should have put a decimal. Got bugs flying around in here. Good grief. 12,500. Yep, once again, from here to here, multiplied by 2.5. I'm going to check this last one way down here. That 5 was horrible. 78125 divided by 31,250. Yeah, all the way down the board. We're multiplying by 2.5. So this is exponential. What kind of model describes the data? It is exponential. All right. Exponential function. Number 20. Use the information in the table to predict the number of termites in a termite colony after 1 year. And here we're talking population. I'm guessing this is going to be quadratic. I'm sorry, exponential. My time is increasing by 1 month. I need to figure out what my common ratio is here. So if you take 180 and divide by 60, your common ratio is 3. If you take 540 and divide by 180, your common ratio is, we're multiplying by 3. And from here to here, double check it, we are multiplying by 3. So I know that y equals a times b raised to the x. I have a starting population at time equals 0 of 60. My common ratio is 3 raised to the t. And they want to know after 1 year. Well, this is months. So 1 year is 12 months. So it's going to be 60 times 3 raised to the 12. What do you get? Woo-wee! Holy moly! I get 31,886,460 of those little wood munching dudes. Is that what you got? Yeah, great. Or not so good, I guess. All right, I've got a couple more problems here that's not on your review from lesson 11-1, geometric functions or geometric sequences. So let's cover that. All right, with geometric sequencing, do you guys remember the formula? Take a look at your notes. All right, for a geometric sequence, a sub n equals what? A sub 1, the first term in your sequence, times what? Yeah, your common ratio raised to the position number minus 1. All right? That's your basic formula. Everything else from there is pretty easy. Okay, on number 1, it says find the next 3 terms in each geometric sequence. You just need to know what is it you're multiplying by to get from 3 to 6, to get from 6 to 12, to get from 12 to 24. Yeah, we're multiplying by 2 each time. So you just go ahead and multiply by 2. 24 multiplied by 2. The next term in that sequence is, 48. Multiply that by 2 and you get what? 96. Multiply that by 2 and you get what? 192. Yeah, that's pretty easy. Okay, on number 2. Negative 1 to 2 looks like you multiplied by what? What's your r here? Yeah, your r is negative 2. Negative 1 times negative 2 is positive 2. Positive 2 times negative 2 is negative 4. Negative 2 times negative 2 is positive 8. So now keep going the next 3 terms. Negative 2 times positive 8 is negative 16. Negative 2 times negative 16 is positive 32. Positive 32 times negative 2 is negative 64. Yeah, there we go. All righty. Take a look at this one. What are you doing here? You took negative 2,400 and multiplied by what to change it into negative 1,200? Negative 1,200 multiplied by what gives you negative 600? Negative 600 multiplied by what gives you negative 300? Yeah, they're dividing by 2 each time, which is the same as multiplying by half. So what's the next 3 terms in the sequence? Negative 150. Negative 150 divided by 2. We get negative 75. Then take that and divide by 2. And the next term is negative 37.5. Yeah, pretty easy. Alrighty. Number 4 says, the first term in a geometric sequence is 2, and the common ratio is 3. What is the 8th term in the sequence? Yeah, you just have to pop those into the formula. A sub n, well actually this is going to be a sub 8, that should be an 8 right there, equals your a sub 1, the first term in the sequence, multiplied by your common ratio of 3, raised to the n minus 1, 7th power. So that's going to be 2 multiplied by 3 raised to the 7th power. I got 4,374. What did you get? Hope we got the same thing. Okay, number 5. The table shows the distance swung by a pendulum during its first 3 swings. The values form a geometric sequence. What will be the length of the 7th swing? Well, you could take that table all the way down to 7, or you could call your n equals to 7, and then you just have to find out what your common ratio is. If you take 800 and divide by 1,000, what do you get? If you take 640 and divide by 800, what do you get? Yeah, I got multiplying by 0.8. So my a sub 1, the first term in the sequence is 1,000, multiplied by my common ratio of 0.8 raised to the n minus 1 and a 7, so 7 minus 1 is 6. Multiply that out. Let's see what you get. 1,000 multiplied by 0.8 raised to the 6th. What'd you get? I got 262.144. Did they tell us how to round? No, they didn't. I'm just going to call that centimeters. Is that what you got? Good. That's what I got. Okay. Take a look at your notes, and I'd say you guys are ready for this short little test. Good luck, guys.